This presentation will go through balancing chemical equations. So the chemical equation we're looking at today is hexane burning in oxygen. So we've got our hexane, which is our C6H14, plus our oxygen, and when we burn that, it forms carbon dioxide and water. So to start this process, we need to work out how many atoms of each type are on each side of the equation. So let's start looking at our atoms. So carbon atoms, on the left-hand side we've got 6, on the right-hand side we've got 1. So immediately they're not balanced because they should be equal. Look at the hydrogens, same problem. 14 on the left side, 2 on the right, and oxygen, 2 on the left-hand side, and then 2 in carbon dioxide and 1 in the water makes 3 on the right. They're not equal. And because these aren't equal on each side, it means that the equation is not balanced, and we have to work out then what ratios they need to react in to get a balanced equation. So, where do we start? That's probably the hardest part for each student to work out. Where do you start on something like this? Well, it's probably best to start with the largest number of atoms. And in this case, hydrogen has 14, well, there's 14 hydrogen atoms on the left-hand side. So let's start with this one. Now we need to get the same amount on the other side. At the moment, we've got 14 on the left and 2 on the right. To make both sides equal, we have to get 14 on both sides. So what we've done here is we've actually, on the right-hand side, multiplied water by 7, because 7 times 2 is 14. So let's have a look at our equation. We've now got this equation with the 7 waters. So let's look at the numbers of atoms on each side of the equation. We've still got a problem with carbon, so we'll deal with that in a minute. Our hydrogens now are equaling each other, so they're balanced. But our oxygens are still a problem because there's 2 on the left, and with the change in water, there's now 2 for carbon dioxide and 7 for water. That makes 9. So we're still not balanced. So we have to do some more work. One of the hints that is important to pick up is that on the left-hand side, we've got O2, which is the oxygen molecule. So every number that we multiply that by is going to be an even number. But if we put the 7 outside of oxygen, of hydrogen, water, we've got 14 hydrogens, but we've got 7 oxygens, which is an odd number. And our problem is we're never going to make that an even number unless we make this an even number in the front, the 7. So how do we do that? We're going to change the number of oxygen in water so it's an even number. And the only way we can really do that is to double the 7 and make it 14. That will then allow the oxygens to be an even number, and it also still is a multiple of the number of hydrogens that we need. If we've got 14, then we can double that and make that 28. So if we do this, our equation now becomes this with the 14 waters. So let's have a look at how we're going on our balancing. So here's our equation with our 14 waters now. Let's look at the atoms on each side. We've still got a problem with carbon. 6 on the left, 1 on the right. Now we have a problem with our hydrogens because we've got 28 on the left, but only 14 on the right. So we're going to have to double these. Our oxygen, we've got 2 on the left and we've got 16 on the right. Well, we're still having a problem. 2 from the carbon dioxide and 14 from the water. Okay, so how do we do this? Well, now there's twice as many hydrogens on the right as the left. So what we could do is double the amount of hexane, put a 2 in front, and if we do that, the equation now becomes 2 hexanes plus oxygen gives carbon plus 14 waters. So let's have a look how our equation is going as far as atoms on each side. Here's our equation with the 2 hexanes and the 14 waters. Let's look at numbers on each side. We've now got our double the number of carbons. So we've got 12 carbons, 2 times 6, but we've still only got 1 carbon on the right-hand side. So carbon is a problem. Our hydrogens are now in balance, which is great. So we've got somewhere there, but our oxygens are still 2 on the left-hand side and 16 on the right. So it's not balanced. So how can we do this? Well, we're going to have a look at the carbon atoms and see what we can do there. So what we can do is we've got 12 carbons on the left-hand side, but we've only got 1 on the right-hand side. So we need to multiply the carbon dioxides by 12. So let's have a look at what we've changed now. We've got our 2 hexanes plus our oxygen molecule going to 12 carbon dioxides and 14 waters. Is that going to balance? Well, let's have a look at our equation. 2 hexanes, 1 oxygen molecule goes to 12 carbon dioxide molecules and 14 waters. We'll do the atoms on either side. Our carbons now match, which is good. Our hydrogens match, which is great. But we have a problem with the oxygens. We've now, because we've multiplied the carbon dioxide by 12, that will give us 24 oxygens plus our 14 oxygens in water give us 38. So we still have a problem with our oxygen. How are we going to deal with that? Well, we've got our oxygen molecule on the left-hand side, which we can multiply and change the ratio of. So how do we do that? To get that matched on the left-hand side, because there's 38 oxygens on the right-hand side, and our oxygen molecule has 2 oxygens on the left-hand side, we're going to have to multiply our oxygen molecule by 19. So our equation now becomes 2 hexanes plus 19 oxygen molecules goes to 12 carbon dioxides and 14 waters. Let's see how we're going with our equation. So here's our changed equation. 2 hexanes plus 19 oxygen molecules goes to 12 carbon dioxide molecules and 14 water. Let's look at our numbers of atoms. Carbon are now 12 on each side. 2 times 6 is 12 on the left, 12 by carbon on the right. So that's good. Hydrogens, 2 times 14 on the left gives us 28. 14 by 2 on the right gives us 28, which is great. Now, oxygens. On the left, 19 by 2 gives us 38 oxygens. And on the right, 24 from the carbon dioxide, 2 times 12, plus 14 from the water, 14 times oxygens, totals to 38. And there we have it. We have our balanced equation. Why? Because the same number of atoms exist on each side. And by doing this, you can go through and change the ratio of each of these molecules to each other to find out how they react. The key to this is finding a way that's going to work for you. This is a suggested way to start, and it does take a little bit of time. And once you've done this a few times, you get better at it. Good luck with your balancing.